Infra-Bayesianism is a mathematical toolkit. And to a lot of people, it looks like a bunch of obscure math that could be tucked away in the dusty pages of some obscure math journal. For a lot of people, it can be difficult to imagine how this mathematical framework could be applied to align AGI. Connell and I have several goals for this video series, but one of the main goals is to give you a sense of how IB could plausibly help with alignment. One thing that helped the two of us build a better picture of the role of IB in helping us align AGI was to situate IB within a larger alignment research agenda. Vanessa Kosoy and Alex Appel invented IB in the hope that it would help enable progress on one branch of Vanessa's research agenda. Each alignment researcher has their own research agenda, their own mental map of how to arrive at a solution to the alignment problem. Vanessa's agenda is called the Learning Theoretic Alignment Agenda, and we're going to be going in depth on her full agenda in a later video here shortly. But in this video, we're going to zoom out one step further and motivate the Agent Foundation's research framework, which is a class of research agendas centered around becoming less fundamentally confused about basic questions related to agency. Vanessa's Learning Theoretic Alignment Agenda is one example of an Agent Foundation's research agenda, and IB is a piece of the puzzle in Vanessa's agenda. One thing I want to make clear here is that you don't need to be enthusiastic about Vanessa's entire research agenda in order to think that developing IB further is worth the effort. IB helps solve a particular theoretical problem called non-realizability, which we'll be defining later. And non-realizability pops up in lots of research agendas, not just Vanessa's research agenda. To help you understand the Agent Foundation's research agenda, I want to start off by telling you a story. Once upon a time, in a land not so far away, there was only a single unicorn left in the world. The people of this world loved their unicorn and longed to protect it as long as they could. One day, a prophecy came down that at some point in the next 10 to 80 years, a demonic red bull would enter their world and slay the last unicorn, unless the people could come up with a way to stop the bull. A council of mages immediately got to work drawing up plans for how to protect the last unicorn from the red bull. They settled on the idea of doing research to create a spell to turn the fearsome red bull into a harmless rutabaga, but they were split over which type of research agenda was most likely to successfully produce such a spell that had a good chance of actually working. So they split into two sub-councils. The first sub-council, the Magic Infrastructure Research Institute, or MIRI for short, believed that in order to make any real progress towards crafting the desired spell, the community of mages desperately needed to become less fundamentally confused about basic questions related to the craft of magic. For years, mages had been working with magic without really understanding how it worked. This informal understanding of magic worked just fine for everyday uses, but MIRI believed that the spell needed to turn a red bull into a rutabaga would be of a fundamentally different sort than any spell they had ever used. No one had ever attempted magic on this scale before. MIRI strongly believed that the magical community needed to build a mathematically formal understanding of magic if they wanted to have any hope that their eventual spell would have the desired result. They proposed a research agenda centered around answering the question, what is magic, really? They proposed making progress in linguistics in order to better understand the nature of spoken spells, and working on further developing the field of chemistry in order to better understand the nature of potions. One of their spokespeople argued to the wider council, saying, our field isn't even at the point where we have a mathematically formal answer to the question, what does it mean to turn something into something else? Are we talking atom for atom transmutation, or do we simply mean imprisoning the soul of one thing inside the walls of another object? Or does turning one thing to another thing consist of some entirely other fundamental process? Okay. Until we gain clarity on these sorts of fundamental questions, we can't hope to make progress on actually crafting a useful spell. We propose the Magic Foundation's research agenda as by far the most likely way to make progress towards saving the last unicorn and preserving our future. The spokesperson for the second sub-council, called Red Bull Research, said, look, maybe the eventual spell we come up with will need to look fundamentally different from all the spells the magicians have been using for millennia. In that case, we agree that the kind of foundational research you're doing makes the most sense. But it's plausible that we can just come up with a spell that will work that is basically a souped up version of the kinds of spells we've been using so far. When we cast spells, we sprinkle fairy dust on our wands. More powerful spells require more fairy dust. Maybe coming up with a spell to transform a red bull into a rutabaga is as simple as collecting loads and loads of fairy dust over the years, sprinkling all of it on a mega wand, and chanting a spell very similar in cadence and linguistic structure to the spells we've been using all these years. We propose doing empirical research on the spells in our existing spellbook and getting better and better at casting them safely and effectively. For instance, our first research project will be to take the spell that turns a frog into a sparrow and see if we can get more and more precise with it. Sometimes For reasons we don't understand, this spell turns frogs into more dangerous birds like scorpion hawks. Can we come up with a version of this spell that never turns frogs into scorpion hawks and always turns them into sparrows? That would probably yield some insights about how to come up with a way to make sure our spell can successfully turn the Red Bull into a rutabaga. Saying that there's no way to make progress without working on foundational questions is a really strong statement. How can you make that kind of claim with any confidence? We think the work you're doing at MIRI is important, but we also think it makes sense for at least some of us to go off and do this empirical work that has a decent chance of producing valuable insights. As MIRI worked on coming up with a mathematical formalization of magic, they kept encountering the same type of problem over and over. What is the correct way to think mathematically about combining the effects of a bunch of weaker spells together to get a stronger spell? Can we come up with mathematical proofs showing how the effects of the weaker spells interact? They pored over the existing mathematical literature and couldn't find the tools they needed to think about this problem. So they put some of their researchers to work on creating new mathematical tools to think about this problem. Which group of mages ended up being correct, MIRI or Red Bull research? When the Red Bull came, were the mages ready to protect the last unicorn? That's a story for a different time. Now back to the real world. MIRI stands for the Machine Intelligence Research Institute, and their research focuses mainly on agent foundations, sorting out fundamental confusions related to intelligence and agency, and the hope that getting unblocked on these questions will open a path towards a solid alignment solution. By the way, you might be wondering what sorts of questions agent foundations researchers try to tackle. Here's a list of questions that agent foundations researcher John Wentworth uses to illustrate what he tends to think about. He asks things like, what are the most important questions to ask? What approximations work? What do we need to pay attention to and what can we safely ignore? How can we break the problem system into subproblems and subsystems? Is an E. coli an agent? Does it have a world model? And if so, what is it? Does it have a utility function? If so, what is it? Does it have some other kind of goal? What even are human values? Okay, so I hope you're getting a sense of the kinds of questions that agent foundations researchers will ask. Now, the analog of Red Bull research is Redwood Research, an organization that focuses more on prosaic AGI alignment. Prosaic AGI is a term invented by Paul Christiano to refer to AGI that gets invented without the need for fundamental algorithmic breakthroughs. Paul works at the Alignment Research Center, and here is the Alignment Research Center's logo down below. Paul believes it's plausible that an algorithm very similar to algorithms we currently have will be able to scale all the way to AGI just by putting more computational power behind these algorithms, much like the Red Bull research envisioned sprinkling more fairy dust on their wands. In Paul's view, if we do end up with prosaic AGI, then doing empirical iterative engineering work on current machine learning systems to try and make them safer, trying to come up with a frog transformation spell that always produces sparrows and never produces scorpion hawks, this kind of research is likely to yield insights that will be useful for aligning AGI. Any ideas about alignment that have popped up in the field recently, like whether they're your own ideas or whether they're someone else's ideas that you're especially excited about?
I certainly find Paul Christiano's work very interesting. So he's kind of thinking about these questions very informally, which is on the one hand unsatisfactory from my perspective. On the other hand, he does generate a lot of ideas, which I find useful and which definitely entered my thinking about the problem. And John Wentworth's research is also, I think, fairly interesting, but I'm still not sure exactly where is it going, but it might be going to some really interesting place.
Now, in reality, the fairy tale I presented in this video is an oversimplification of the disagreement between agent foundations folks and prosaic alignment folks. There's no clean split between these two camps. It's more like a spectrum, and different researchers and organizations fall at various points along this spectrum. And sometimes a single researcher will hop around to different points on the spectrum. Also, even among people who pursue the agent foundations research agenda, there's considerable disagreement about which research directions within agent foundations are most fruitful. As I mentioned above, John Wentworth is an independent agent foundations researcher, and he has been quite critical of MIRI's agent foundations work. Vanessa Kosoy is affiliated with MIRI, and John's agent foundations agenda looks quite different from Vanessa's agent foundations agenda. John is quite skeptical of the value of Infra-Bayesianism, and we're going to take a look at his reasons for skepticism in a future video. Here's a back and forth between John and me about agent foundations. When I was a junior in college, I took this class called Real Analysis, And my professor at the, one of the first class periods, he was telling us, you guys, what we want to do in this course is prove things about real valued functions, but you don't even know what the real numbers are yet, right? You don't have a good understanding of what they actually are. So first, we need a good understanding of what the real numbers are. So that's a metaphor that I use to think about agent foundations. Seems like agent foundations people think that we need to get a really good handle on the definitions and the concepts, and really formalize concepts that are central to questions of agency.
All right, so first of all, I like the analogy to real analysis, but I'd say, like, for any modern person, that analogy is probably going to be misleading, because, like, we already know how to define the reals, right? You go into real analysis class, they'll explain the whole thing to you, it works great. You have to think of it from the perspective of someone who didn't know how to do that the first time, right? Like, we had this intuitive idea of real numbers a long time before we had rigorous definitions of them or had any idea what went wrong with other definitions of them, right? And, like, from the perspective of someone like that, the problem is not just, like, coming up with a definition, it's coming up with a definition where you can start from that definition, then derive a bunch of properties, and those properties will all match the sort of things that we see in the real world when we try to use real numbers, right? So, like, first you need some definition that'll tell you where you can use real numbers to model the actual world. And you want that to, like, mostly match the sort of places you expect to be able to use the reals. And then you need to be able to derive a bunch of useful stuff from it and have those predictions you derive to actually match the places in the real world where we use the real numbers, right? So it's a very different process than how, like, a math student in a real analysis class would engage with it. Make sense?
Yeah, it's much more creative and requires much more creativity and original thought than just passive absorption of what's already been invented.
Yeah, so part of it is the creativity. Another piece is, like, it's much less a focus on, like, the math and much more a focus on, like, taking your own intuitions and figuring out the right way to express them. Right?
Got it. Yeah.
You want to, like, be making theory that's going to match a bunch of stuff in the real world.
Yeah.
Whereas real analysis, we don't really talk about the real world very much in real analysis class.
Right. So I just made a claim as well that it seems to me from, my experience with reading Agent Foundations stuff that Agent Foundations researchers are really after three key definitions: intelligence, agency, and values, which seem to be really closely related. Does that seem accurate? Are there things that I'm missing? Are there things that you would throw out? What do you think?
I would say I roughly agree with that. Like, that's a reasonable summary of, like, the big three things we need in order for actual use cases. I would say a big part of the way we know that we got the right definitions is that we also end up with a bunch of definitions for related concepts. So, like, if we have a good definition of agency, we'd also expect to see things like definitions of world models or embedded representations or optimization or search processes, things like that, just sort of naturally popping out of it or going into it, right? So those big three are a reasonable summary for, like, the end goals, but then you also need you need, like, a whole network of stuff to support it.
Why did you choose to work on agent foundations in particular? I imagine that maybe both personal fit and your beliefs about which research is most promising for alignment played a role here.
So in my case, before I was working on agent foundations for, like, AI and alignment, I was thinking about problems in economics and in biology. So things like, in biology, we talk about bacteria as wanting things or as trying to achieve things or as modeling the world around them. Like, we're talking about them as agents, but we don't have mathematical ways to talk about them as agents. That's sort of a big intuition driver, but it's not a driver of the math. And it seems like we could model these systems a lot better if we had the math for it. And then similarly in economics, it's useful to model markets as optimizing for things. And yet, if you look at the standard models of markets that we use in economics, it turns out that markets are not in general expected utility maximizers. And you're like, okay, well, how am I going to model a market as like something agenty, right? So I was running into these problems in biology and economics and thinking about like basically how to do agent foundations in those contexts. And then Miri came out with the embedded agent sequence, which was talking about essentially the same problems in the context of AI. And I was like, they're thinking about the same problems here. I should like go do that.
One objection that I can imagine someone raising here is that, maybe someone is totally on board with the idea that eventually we will need mathematically tight definitions for these concepts if we at all hope to hit the small target of AI alignment. But maybe they're thinking to themselves, like, do we really need, like right now, before we can make any substantial progress, do we really need them? Do we really need those definitions right now? Or is it that it matters that we get them eventually? Maybe we can, much like a mathematician would really tune up their intuitions for a problem first and then sharpen those up in proofs. Maybe a good strategy is to work with our intuitions for now, and then eventually that will lead to formal definitions. Why might that not work? Why do we need the formal definitions like all the way toward the finish line?
So two answers to that. So for an analogy here, think about like information theory. So information theory was like one of the closest analogies we have for what we want to do with agent foundations, but like it was specifically for information and communication, right? And if you think about like how much impact does work have on our understanding of information and communication, basically everything before information theory mattered mostly insofar as it got us to figure out information theory, right? Like we just like really didn't have a clue what was going on before that. We were just sort of hacking stuff together. It kind of works sometimes, but like we really didn't understand what was going on. Like we had some, like you can use correlations, for instance, to measure information, and like people would use correlations to like analyze telephone systems, right? And like you can do about that well, and you can do a dozen different things that will all work about that well, and you're just not really going to do much better without a more powerful theory. Like you can do a dozen different things there, and they're not going to build on each other. They're not going to play particularly well together. It's just going to be a big mess. So my claim here is that like if you want to do any better than sort of the simple default things, what mostly matters is how quickly you can find the nice theory, right? And just spending a long time digging into the intuitions is sometimes the right thing to do to accelerate finding that theory. So like that may be the right call in some cases, but like the point of that is not to like dig into your intuitions in hopes of just like directly building a better system from them, because like that's just not very, very realistic. You're not going to get most of the bang from that. But if you're doing that to find the theory, that's a reasonable argument.
Now, when we say that we're after formal theories eventually, does formal always mean mathematical, or can formal take other forms other than mathematically formal?
Yeah, that's a good question. I wouldn't want to rule out other forms in principle, but in practice, we sure don't seem to have any sciences that have ever like built up anything particularly impressive on anything besides mathematics.
Now, if someone's trying to choose between the more theoretical agent foundation side of alignment research and the more applied empirical engineering side, what factors do you think they should consider? And I guess I should also say, do you think this is a false choice? Do we not have to choose between the two?
Yeah, so first of all, I think the sort of perception of the divide between those from outside the field is different from what it looks like from like my perspective, for instance. So like there's a lot of work. So if you're actually, let me ask a clarifying question. Are you talking about like sort of applied experimental work on agent foundations, or applied experimental work on like ML and alignment more generally?
Yeah, I guess I meant more of the research directions towards like prosaic AI alignment. Yeah, like working with large language models, stuff, the type of things that Redwood and Anthropic are doing.
Right, sure, okay. So I think most people who are working on like prosaic alignment models are mostly working on those rather than agent foundations, just because they have absolutely no idea how to make any progress on agent foundations by doing empirical work, right? And like, insofar as that's true, like if you just aren't going to be able to make any progress on agent foundations, you have no idea where to start, then like, whatever, I guess. There's not much point to working on it, right? Like, I'd certainly hope that people actually go try it for a bit and see if they like actually can't make any progress. But like, you know, if you can't make any progress, then there's not much point working on it. Certainly, I think for people who could work on either, they're just like far better served by working on agent foundations work. And that doesn't necessarily mean doing pure theory work. Like there's lots of space for experimental stuff in agent foundations.
So on the spectrum from pure agent foundations researcher to pure prosaic alignment researcher, Vanessa Kosoy is pretty far on the agent foundation side of the spectrum. In the fairy tale, the Magic Infrastructure Research Institute kept encountering a theoretical problem that they solved by inventing a new mathematical framework. That's exactly the type of thing that Infra-Bayesianism is. It's a mathematical framework for dealing with the problem of non-realizability that kept popping up over and over again in the Machine Intelligence Research Institute's theoretical research program. So now that we have an understanding of what motivates some people to work on agent foundations research, we're going to take a closer look at Vanessa's research agenda. If you would like to dive deeper into the ideas presented in this video, I recommend that you have a look at the following 4 resources. All of them are pretty short, right? You could probably read all of them in under 2 hours or so. I will see you in the next video.